In this lesson, we are looking at compression. All right, we need to know what's meant by the term compression, know why there is a need to use compression, and the next one is basically the same as point 2, identify common scenarios where compression may be needed. So, start off with dead easy. What do we mean by compression? Well, it's removing data from a file, right? And we'll talk a little bit more about what data is removed and how that happens a little bit later. So why on earth do we need to do that? So first off, to reduce the storage space that we needed. So if you think about a mobile phone, when you take a picture, you don't want those pictures filling up all of your memory really, really quickly, or when perhaps you are watching television, when the video perhaps is streaming over the internet, you want it to do that quick enough so the image displays nice and smoothly on your screen. So in terms of for network providers, that it can help to reduce the amount of what we call bandwidth that's needed, right? Because imagine you've got 10 million people tuning in to watch a TV show, right? If you use compression, then it helps to make sure that all those 10 million people can watch the show and it's all nice and seamless and smooth, right? So it helps. So compression can really help to send data really, really quickly and to reduce storage requirements. They are your two main points, really. I know there's 3 on there, but points 2 and 3 are essentially the same. So here I've got a bunch of files, and so uncompressed it's 3 megabytes, but after compression then it's only 1 megabyte, and here I've got this now single file. So what the computer has done is it's removed some of the data and converted all these files into a single file. Now, the computer can't make use of that compressed file until it's been uncompressed, right? Note the term, it's uncompressed. It's not decompressed, it's uncompressed. So we looked at why it's needed, right? And we know what it is. So this is just a little bit more elaboration on that. So common scenarios which I've come up with. So on a digital camera, you might have noticed sometimes you have different settings, whether you want to use basic fine or ultra fine quality when it comes to taking a picture. And obviously the higher the quality, the more storage space the images are going to take up. But if you lower the quality, then you can fit more images onto your card. So maybe if you're on holiday somewhere and you've taken lots and lots of photos and you're running out of storage space, you might want to reduce the quality of the images, and then you can store more onto the camera. So preparing media for the web. So if you create websites like this website, for example, there's images throughout this website, and I often think about, okay, what kind of format am I using to store the images in, and am I using a suitably compressed format? So it will, so the image to the website will download nice and quickly. And when it comes to video streaming, if I want to make the most of the available bandwidth, then I might need to decrease the quality of the image, or increase the compression that's used so that the video streams nice and quickly. So there's 2 fundamental forms of compression. Is what we call lossy and lossless compression, and you need to be clear about the difference between the two and when you might use each of them. So know the benefits and drawbacks of lossy compression and describe the effect that lossy compression is likely to have on file size. So lossy compression will permanently remove data from files, right? So it's impossible to get to the exact original, right? Now with lossy compression, you can get a huge amount of compression, right? So I don't know if I've given examples yet. Here I've got a 24 megapixel image, right? If it's uncompressed in memory, it's going to be something like 68.66 megabytes. Okay, but if I compress the file using lossy compression, I can get a huge amount of compression. So now the file is just 13.8 megabytes. It's similar for MP3 files, right? Uncompressed audio is on average about 10 times bigger than a compressed MP3 file, but it does use what we call lossy compression. So with images, we could use JPEG lossy compression. With audio, we use MP3 lossy compression. With video, we use MP4 lossy compression, which is what I'm using now. But of course, there's always going to be a trade-off. Always going to be a trade-off. Now, the issue with lossy compression is, although we get really high, fantastic, amazing compression ratios, i.e. we can save a lot of storage space, the quality can sometimes be questionable. So if we compress data too much, if we compress the quality of an image too much, it's going to become a little bit pixelated. We see all the artifacts. If we compress audio too much when it comes to MP3, the audio is not going to sound very good. It can start to sound a little bit tinny. And the same with video as well. If we use too much compression, it will appear very blocky on the screen, and the sound will sound a bit tinny and awful. So lossy compression can be good in terms of we save a lot of storage space, but we do lose quality. And there's a little video here you can play to get an idea of how much compression we use and the impact that has. We'll come back to this image a little bit later on. So, the benefits of using lossy compression: we get amazing compression ratios, we save a lot of space. The drawback is there can be an issue with quality, we can lose quality. So the effect that lossy compression is likely to have on file size is it's going to make the file size a lot smaller. So that's lossy compression, where we remove data permanently, so it's in such a way that it's impossible to get back to the original. Lossless compression works in a slightly different way. So again, when we compress the file, it will remove data from the file, but it will remove it in such a way, it's like a magical way, where all of that data can actually be put back when the file is decompressed. Right? It uses a special kind of extrapolation technique, I suppose, is one way of explaining it, where it can look at the data in a compressed file and work out what data is missing and put that all back in, and we can get back to the exact original. Right? So because we can get back to the exact original, then after decompressing the compressed lossless file, hope you're following this, it means we can get back to the exact original, so all the data is going to be absolutely perfect. We're going to get maximum quality, right? But the drawback of lossless compression is we don't tend to achieve quite so high as a higher compression ratio, i.e. we can't compress the file quite so much, so it's still going to take up quite a bit of storage space. So when it's essential that the original data needs to be restored, then we've got to use lossless compression. So if you think about text in a book, right? Imagine we've got an electronic file that contains a book and it just contains text. Obviously, for something like that, we want to use lossless compression because we want all the text back so we can read the book later. But something like an image, we can get away with using lossy compression because it doesn't matter if the image isn't quite perfect when we decompress it. That doesn't matter at all as long as we don't use too much compression. All right, so you need to think about when you might use lossy and when you might use lossless compression. Here's a few file formats. So zip is a very common file format which can be used to compress, tends to be more text-based type files. PNG, you might have seen those on the internet, is used to compress image data. FLAC is one for audio files, and H264 lossless version is something that we can use for high quality lossless video should we wish. So what's the difference? Do you think you can explain the difference to me right now? What's the difference? Go on. Okay, what are you thinking? So both techniques are used to remove data, but with lossless compression it's possible to get back to the exact original, whereas with lossy you can't. So lossy compression tends to achieve the greatest possible amount of compression, but at the expense of quality. So this diagram is quite good for explaining the difference. So here we've got the original file. So if we compress it using lossy compression and then decompress it, we don't get back to the exact original. But if we use lossless compression and then decompress it again, we can get back to the exact original. So that's going to be really good if we've got a file and we want to edit it later on. Now something that's worth noting about JPEG images. JPEG images. So JPEG uses lossy compression, and every time you save that image with a JPEG, it's going to lose a certain amount of quality. So when you're editing a image file, you really don't want to be using JPEG. You only really use JPEG once you get to the final image that you want, and then you can output it as a JPEG file. So hopefully you know what's meant by the term compression. So when we remove data, you can think about scenarios of when it might be needed, and you know the benefits and drawbacks of lossy compression and the effect that that will have on file size, and also the benefits and drawbacks of lossless compression and the effect that that's likely to have on file size. So make sure you can do that and you're confident with that. Again, there's quizzes on here and some flashcards to help you.